All right, so this is video 3 on my guide to learning C. So today we're going to make our first hello world. So this is a bit of a rite of passage that every time you learn a language, this is the first program that you would usually write. So the goal for the day is to sort of learn how to print stuff, right? So let's kind of get started, okay? So I've realized that a few notes from last time. So hopefully my noise suppression is working now. And I've also realized that I did not explain what a compiler is. So I'm just going to get into that really quick. I won't go into the details. But what the compiler basically does is, so you have to understand that computers can't really understand text as is, right? Like, so whatever you write in C or Python or whatever, at some point gets converted into like binary. So binary is just ones and zeros, right? So we kind of need to, so we need something that converts our code into binary so that we can run it, right? So that thing is called a compiler in this case. Some languages use an interpreter and some languages use both. But in the case of C, we use a compiler, and our compiler is called the GCC, the GNU C compiler. So yeah, that's sort of it. So let's just jump right in. So let's jump into the program real quick. So as you can see, a bunch of comments already. So I'll just walk you through this once, okay? So as you can see, the return 0 and main is the same as last time, except for we have two new things here. On line number 9, we have this include, right? So you have to understand that, like, if you have any experience in programming in any other language, you would know how external libraries work, right? Or like, packages in the case of Python. So what that basically means is, for somebody who doesn't know, it's kind of like you have code that exists that was written by someone else, somewhere on your computer or remotely, that you can call within your code to use it, right? So what this means is we're basically including this file called stdio.h that's stored somewhere on the computer, okay? And within this file, stdio.h, there is a function called printf that is defined. And we are using that function to sort of do something, right? So in this case, we're using printf to display whatever string we've put here, right? So if you ever want to write your own H files, you can do that. So if I were to let me show you an example, right? I can show you something that I wrote. Okay. So as you can see here, there's a bunch of H files here, right? I'll just ignore the rest. So let me open, say, image utils. That's pretty basic. Oh, my bad. Yeah. So image utils is basically like, it looks a lot like a C function. It is a C file, except for there's no main, right? And we've defined one function here, right? Save image ppm. Again, you don't have to get into it, right? So all you really need to know is H files are basically places where we can define and write functions so that we can reuse them in other places over and over again without having to sort of copy the code and everywhere. Okay, so that makes things really easy for us in more than one way. One, it reduces the total number of lines in our code base, which is a very important thing to do, because if you have a lot of redundant code, maintaining it is a pain, right? Second thing is, if you want to add or change the functionality of a certain function, right? You don't have to go and modify like 100 different places. You can just change it in the H file, and every place that sort of calls this H file, or includes it, will sort of have those changes reflected to them as well, right? And the last thing is, it just makes our code significantly more modular and clean. So I can sort of focus on the actual problem than have to worry about the logic of a problem I've already solved. So yeah, that's kind of it for include files. So as we can see here, we're asking the computer to print the string hello world, right? So I can just go right ahead and first compile it. Again, I've saved it like a dot demo thing. So I've saved it to a demo binary. I run demo, it says hello world. So yeah, that's kind of all there is to it. Okay. So I will also cover a few other things in this video, namely, you know, coding practices. Okay. So there are different ways in which you could sort of, so C is a compiled language, right? So you can sort of get away with many things. So like if it was in Python, indentations are very important to the actual structure of the code. But in C, that's not really true. We use brackets, right? So even though your program might sort of compile, you ideally want to sort of follow a few guidelines so that it's easy for you and for whoever else will maintain your code in the future to sort of read it and understand what's going on, right? So the very first thing you want to be doing is writing a lot of functions. Okay, and a lot of, sorry, comments, right? So, okay, my example here is very overkill, but in general, whenever you're declaring a function of any sort, you kind of want to explain what exactly is going on in there so that the person who comes after you will know what to do with that function. Second thing is if you use any magic numbers, right? So if you're doing some calculations, like say I want to write a function that calculates the volume of a sphere or like a circle's, area, right? So in that case, I might just hard code 3.14 or the value of pi into the function, right? So although it's very evident for us since, this is a very simple and, ubiquitous formula, if this was something more complicated or niche, there's a very high chance that the person who comes after you will not know what that magic number or 3.14 is in this case, right? So whenever you have something of that sort, which requires like domain knowledge or knowledge that you have specifically, you might want to mention that. Second thing is when we come about to variables and stuff like that, you might want to start using very descriptive names. It doesn't have to be very long, but as long as it gets like the message across, it's good enough. Something like A, B, C, D is usually discouraged. I mean, if you're doing like some math stuff, maybe it's okay. Like if, say, for whatever reason, you're going to use a quadratic equation formula to find, the roots of an equation, right? So it'll be like, again, b squared minus plus minus, oh my God, I forgot. Minus b plus minus square root of b squared minus 4ac divided by 2a, right? So in this case, anyone who knows the formula will sort of know what a, b, and c are, right, in this case, which is the coefficients of the terms in the equation. But in this case, I mean, I guess it's fine to use a and b, but ideally, I would suggest using, more descriptive names. And finally, keep it simple. KISS. Okay, keep it simple, stupid. Okay. Yeah. So that's kind of all there is to it. And although this last bit might depend on your preferences or your company's work style or whatever, you want to use a formatter, right? So in my case, I use the formatter that comes with CLang. I think it's CLang format. So if I want to say this, right, it'll format the thing and give it to me. And if I pass the I thing, it'll format it in place. So yeah, that's kind of it, just make your code readable, clean, and yeah, that's kind of all the basics for the common courtesy and guidelines writing C code. And we've learned how to print stuff today. So in the next video, we can sort of move on to more complicated things, hopefully, and learn to have fun. If you have any questions, just let me know. That's sort of it for today. Thank you.